wonders of space exploration, reaching for the stars. Right now, as you watch this video, you're hurtling through space at 67,000 miles per hour, aboard a blue marble called Earth. Above your head, a space station the size of a football field orbits at 17,500 millimeter May, while robotic explorers drill into Martian soil 140 million miles away, and a probe launched in 1977 continues transmitting data from beyond our solar system after traveling for nearly half a century. We live in the golden age of space exploration, where humanity has transformed from earthbound dreamers into cosmic pioneers. Welcome to this deep dive into the greatest adventure in human history, our quest to reach for the stars and unlock the secrets of the universe. The dawn of the space age. Space exploration began not with rockets but with dreams. For millennia, humans gazed at the stars and wondered what lay beyond our atmospheric prison. The transformation from dreamers to space travelers happened with breathtaking speed. In just 12 years, we went from launching our first artificial satellite to landing humans on the moon. October 4, 1957, marked humanity's first step into the cosmic ocean when the Soviet Union launched Sputnik 1. This basketball-sized metal sphere, weighing just 183 pounds, fundamentally changed our species' relationship with space. Its simple radio beeps announced that the space age had begun. The early space race pushed technological boundaries at breakneck pace. Less than 4 years after Sputnik, Soviet cosmonaut Yuri Gagarin became the first human to orbit Earth on April 12, 1961. His 108-minute flight demonstrated that humans could survive in space. Gagarin's famous words, "I see Earth, it is so beautiful," captured humanity's first glimpse of our planet from the cosmic perspective. This achievement spurred America's ambitious response. President Kennedy's bold declaration to land humans on the moon before the decade's end. The Apollo program became the largest peacetime technological endeavor in human history, employing over 400,000 people and consuming 4% of the federal budget at its peak. On July 20, 1969, Neil Armstrong's foot touched lunar soil, fulfilling Kennedy's promise with 5 months to spare. His words, "That's one small step for man, one giant leap for mankind," marked humanity's transformation from a single-planet species to cosmic explorers. The moon landing proved that seemingly impossible dreams could become reality through human determination and ingenuity. Robotic Pioneers, our mechanical ambassadors. While human space missions capture headlines, robotic explorers have become our most effective cosmic ambassadors, venturing where humans cannot yet go and revealing wonders beyond imagination. The Voyager missions, launched in 1977, represent perhaps humanity's greatest exploratory achievement. These twin spacecraft, no larger than compact cars, have traveled farther from Earth than any human-made objects. Voyager 1, now over 14 billion miles from home, continues transmitting data after 46 years, having crossed into interstellar space in 2012. These mechanical explorers carry golden records containing sounds, images, and greetings from Earth. Messages in bottles cast into the cosmic ocean. Mars has become robotics' greatest success story. Since 1997, a succession of rovers has transformed our understanding of the Red Planet. Today's Perseverance rover, large as a car and nuclear-powered, searches for signs of ancient Martian life while producing oxygen from the Martian atmosphere, a technology demonstration that could support future human missions. These robotic explorers have revealed Mars as a world that once harbored flowing rivers, vast lakes, and possibly life itself. Curiosity rover's analysis has shown that early Mars had conditions suitable for microbial life. Perseverance is now collecting samples that future missions will return to Earth, potentially answering one of humanity's greatest questions. Are we alone? Robotic missions have transformed our understanding of the outer solar system. Cassini's 13-year mission to Saturn revealed the moon Enceladus shooting geysers of water into space, suggesting a subsurface ocean that might harbor life. Titan, Saturn's largest moon, proved to have lakes and rivers of liquid methane, an alien water cycle operating at temperatures that would freeze air solid on Earth. The Hubble Space Telescope, operational since 1990, has become humanity's window into deep space. Its images have revealed the universe's beauty and complexity, from stellar nurseries where new stars are born to the cosmic web connecting galaxies across billions of light years. Hubble's observations helped establish that the universe is expanding at an accelerating rate, introducing the mysterious concept of dark energy. Human spaceflight. Living among the stars. Human spaceflight has evolved from brief orbital flights to permanent residence in space. The International Space Station represents humanity's greatest collaborative achievement, where astronauts from different nations work together 250 miles above political borders. Life in space challenges every aspect of human physiology. Without gravity, bones lose density, muscles atrophy, and fluids shift throughout the body. Astronauts must exercise for hours daily on specialized equipment to maintain physical health. Despite these challenges, humans have now lived continuously in space for over 2 decades aboard the ISS. The space station serves as humanity's orbital laboratory, where microgravity enables experiments impossible on Earth. Protein crystals grown in space develop larger and more perfect structures than Earth-grown counterparts, potentially leading to better medications. The ISS has demonstrated that humans can work together on complex projects despite Earth-bound conflicts. The station also serves as a stepping stone to deeper space exploration. Technologies tested on the ISS, from life support systems to spacewalk procedures, will enable future missions to the Moon, Mars, and beyond. Astronauts have learned to live and work in space's harsh environment, gaining experience essential for longer journeys. Commercial spaceflight has recently transformed human access to space. Companies like SpaceX have dramatically reduced launch costs while increasing reliability. SpaceX's Falcon Heavy can lift massive payloads at a fraction of traditional costs, while their Crew Dragon spacecraft has restored America's ability to launch astronauts from U.S. soil. Technological marvels of space engineering. Space exploration has driven technological innovation at unprecedented pace, creating solutions that often find applications far beyond their original purpose. The challenges of operating in space's extreme environment have forced engineers to develop technologies that push the boundaries of possibility. Modern rockets like SpaceX's Falcon 9 can generate over 1.7 million pounds of thrust, equivalent to the power of 140 fighter jets. These machines must operate flawlessly in temperatures ranging from hundreds of degrees below zero to thousands above, while withstanding vibrations that would destroy most terrestrial equipment. Reusable rockets have revolutionized space access. SpaceX's Falcon 9 boosters can land themselves with pinpoint precision, sometimes returning to launch sites or landing on autonomous ships at sea. This breakthrough has reduced launch costs by an order of magnitude, making space more accessible than ever. Space-based power systems have led to remarkable innovations. Solar panels developed for spacecraft are now among the most efficient ever created, while fuel cells invented for Apollo now power everything from automobiles to backup systems. Radioisothermal generators, using radioactive decay to generate electricity, have powered deep space probes for decades. Miniaturization driven by space requirements has revolutionized electronics. The Apollo guidance computer helped establish the microelectronics industry. Today's smartphones contain more computing power than entire mission control centers from the Apollo era, thanks partly to technologies developed for space applications. Life support systems developed for space have terrestrial applications in extreme environments. Closed-loop systems that recycle air and water aboard the ISS have applications in underwater habitats, remote research stations, and disaster relief scenarios. Scientific discoveries beyond Earth space exploration has fundamentally transformed our understanding of the universe, revealing cosmic phenomena that challenge our basic assumptions about reality and our place in the cosmos. The search for exoplanets has revealed that planets are common throughout the galaxy. The Kepler Space Telescope alone discovered over 4,000 confirmed exoplanets, dramatically increasing the possibility that life exists elsewhere. Some exoplanets defy imagination, Kepler-16b orbits two suns like fictional Tatooine, while others experience winds exceeding 4,500 talus-mepa and likely rain molten glass. Deep space observations have revealed the universe's large-scale structure. Galaxies form vast filaments, and walls separated by enormous voids, a cosmic web stretching across billions of light-years. This structure formed from tiny fluctuations in the early universe, amplified by gravity over cosmic time. Perhaps most mysteriously, space exploration has revealed that 95% of the universe consists of dark matter and dark energy, substances we can't directly observe, but whose effects shape cosmic evolution. Dark matter provides the gravitational scaffolding on which galaxies form, while dark energy drives the universe's accelerating expansion. Space-based telescopes have captured images of cosmic violence and beauty beyond terrestrial imagination. We've witnessed black holes devouring matter, neutron stars colliding in explosions that forge heavy elements like gold, and stellar nurseries where new solar systems are born from cosmic dust and gas. Current missions and future ambitions. Today's space exploration encompasses an unprecedented range of missions, from asteroid sample returns to searches for life on Mars, while ambitious plans take shape for permanent lunar bases and crewed missions to Mars. NASA's Artemis program aims to return humans to the Moon by 2026, this time to stay. Unlike Apollo missions that lasted days, Artemis plans to establish permanent lunar bases near the Moon's south pole, where water ice exists in permanently shadowed craters. This water can be converted into drinking water, breathable oxygen, and rocket fuel, making the Moon a stepping stone to Mars. Mars exploration has entered a new phase with multiple nations launching missions to the Red Planet. NASA's Perseverance rover searches for signs of ancient life while producing oxygen from the Martian atmosphere. China's Tianwen-1 mission successfully landed the Zhurong rover, making China the second nation to operate successfully on Mars. Asteroid missions are revealing the solar system's formation history, while testing planetary defense technologies. NASA's DART mission successfully changed an asteroid's orbit by ramming a spacecraft into it, demonstrating that we might deflect dangerous asteroids threatening Earth. Private companies are revolutionizing space access and exploration. SpaceX's Starship, currently in development, is designed to carry 100 tons to Mars, enabling large-scale colonization efforts. Blue Origin plans lunar landers and space habitats, while other companies develop space tourism and asteroid mining capabilities. The James Webb Space Telescope, launched in 2021, has already revolutionized astronomy with its infrared vision. Webb can peer through cosmic dust to observe the first galaxies that formed after the Big Bang, study exoplanet atmospheres, and reveal star formation in unprecedented detail. Challenges of deep space exploration. Venturing beyond Earth's protective embrace presents challenges that test the limits of human engineering and endurance. The hostile environment of space poses threats requiring innovative solutions and redundant safety systems. Radiation represents one of the greatest dangers to long-duration spaceflight. Beyond Earth's magnetic field, cosmic rays and solar particle events bombard spacecraft and their occupants. These high-energy particles can damage electronics and increase cancer risk. Spacecraft must incorporate shielding while minimizing weight, leading to innovative designs using water, polyethylene, and even human waste as radiation barriers. The psychological challenges of deep space missions may prove as difficult as physical dangers. Astronauts on Mars missions will experience isolation unprecedented in human history, unable to receive real-time communication with Earth due to light-speed delays exceeding 20 minutes each way. Crew members must function as an autonomous team for years, managing conflicts without ground support. Life support systems for deep space missions must achieve near-perfect reliability. Unlike ISS missions where supplies can be delivered regularly, Mars expeditions will depend entirely on closed-loop systems that recycle air, water, and waste for years, while crew members maintain them with limited spare parts. The future of human space exploration. The next few decades promise to transform humanity from a single-planet species into cosmic citizens, with permanent settlements beyond Earth and the technology to reach nearby stars. Mars colonization efforts are advancing from science fiction to engineering reality. SpaceX's Starship aims to establish self-sustaining cities on Mars, while NASA plans to send humans to the Red Planet in the 2030s. These missions will face unprecedented challenges, from producing fuel and water on Mars to growing food in alien soil. Lunar bases will serve as testing grounds for Mars technologies, while providing scientific and economic opportunities. The Moon's low gravity and lack of atmosphere make it ideal for launching deep space missions, while its abundant resources could support Earth's growing energy needs. Space-based solar power systems could revolutionize energy production on Earth. Satellites in orbit receive constant sunlight unfiltered by atmosphere or weather, potentially generating far more power than terrestrial installations. These systems could beam clean energy to Earth via microwaves, providing abundant carbon-free electricity. Asteroid mining represents a potential trillion-dollar industry. A single metallic asteroid could contain more platinum than has ever been mined on Earth, while water-rich asteroids could provide fuel for deep space missions. The resources available in space dwarf Earth's limited supplies, potentially solving resource scarcity, while funding further exploration. Conclusion: our cosmic destiny. Space exploration represents humanity's greatest adventure, our transformation from earthbound creatures into cosmic citizens capable of surviving throughout the universe. Every rocket launch, robotic probe, and astronaut mission carries us further from our planetary cradle toward our cosmic destiny. The technologies developed for space exploration have revolutionized life on Earth, from GPS navigation and weather prediction to medical devices and computer systems. But perhaps more importantly, space exploration has given us a new perspective on our planet and ourselves. The overview effect experienced by astronauts, seeing Earth as a fragile blue marble suspended in cosmic darkness, has inspired environmental awareness and international cooperation. As we stand on the threshold of becoming a multiplanetary species, we face choices that will determine humanity's future. The answers will shape not just our technological capabilities, but our understanding of what it means to be human in an infinite universe. The stars have always called to humanity, but now we have the technology to answer that call. As we reach for the stars, we're not just exploring space. We're discovering the limitless potential of human imagination, ingenuity, and determination. Our journey has just begun, and the greatest discoveries await in the cosmic ocean that surrounds us.
The moment has arrived. This Duel of Concepts deep dive will echo through history. Like, subscribe, and scream your verdict below.